say a few announcements. So tomorrow, the homework on pretty much all the Radiant stuff we did is due. So tomorrow at midnight, so you can turn it in at midnight. Additionally, the test is, of course, next Tuesday in class. I have not received any notification from anyone saying they are taking it online, so that means I'm expecting everyone to show up on Tuesday in class on Tuesday and take the test then. So it'll be a paper test. You'll have the whole class period to do it. You can work on it until, let's see, from 2 to 3:30 if you want to. I don't think there's a class in here after this. So I believe there are 15 problems in total, 4 multiple choice, 4 short answer, and the rest more, a little bit more comprehensive. And I also mentioned I was going to supply some formulas. The formulas, the ones that I will provide, be the law of sines and the law of cosines. Let me make sure about that. Law of sines and law of cosines, and maybe one more formula, a mystery formula, if you may. The geometric interpretation of 2 vectors. That will be, so the cosine of theta is, what's it? Magnitude of u, magnitude of v, something like that. So there's something in the notes called the geometric interpretation of between 2 vectors. That will be the other one I supply, which means all the other formulas you need to know. So I'm giving you law of sines, law of cosines, and the geometric interpretation formula to figure out the angle between 2 vectors. So Tuesday, you have anywhere from 75 to 90 minutes. I mean, again, I'm not going to kick you out until we hit 90 minutes. You take it in class on the following, or this coming Tuesday. And that's really all I can think of before I start going through what to expect on it. So does anyone have any questions before I start going over that? And of course, homework, again, homework's due tomorrow at midnight, 11:59 technically. Because I guess if they were due tomorrow at midnight.
It'll be due Saturday.
Well, tomorrow at midnight would be.
You're right, today.
It would be tonight, but not tonight. So, okay. All trickiness aside, let's go ahead and look at what to expect. So I updated, maybe I shouldn't call it midterm. It's not the midterm. Midterm review. There we go. And this will have, it pretty much goes in continuation off of unit test 1, but primarily the problems will focus on the newer material, which is all on this page. I need to share my screen, don't I? I'm going to do that now before I forget. Okay. So sharing my screen. So for those of you virtually, there's a midterm review here. And so once you click on that, this will pop up. And so expect 1 or 2 law of sine problems. And I gave the 2 situations in which you use law of sines. 2 angles in a corresponding side, 2 sides in a corresponding angle. What does it mean for an angle and a side to correspond to one another? Might be worth remembering. In fact, I should probably simultaneously have Canvas as I sort of talk about some of the cliff notes of the things I'm discussing. So remember, if you have some triangle, just any triangle, and this is angle A, then the corresponding side would be what is immediately opposite of that angle. So those would correspond to one another. Remember, we need this correspondence for the law of sines. What does the law of sines say? Actually, what says one of two things? Namely, and again, this formula will be given on the midterm. Something like this, and then you can replace the b's with c's if you want. But notice that in order to use the law of sines, we need to know at least one of these ratio pairs, at least one of them, which means you need to have a corresponding something, a corresponding angle and segment of something for this to even make sense. If you don't have this, then you cannot use the law of sines. And so the two examples of that being exactly what I wrote here, two angles and one of their corresponding sides, or two sides and one of the corresponding angles. And just any correspondence will make the law of sines actually reasonable. I could ask an application problem using the law of sines. So they might give you two angles and a side, or two sides and an angle, and you would have to decipher whether, if any of these correspond with one another, and if so, using the law of sines versus law of cosines. And then additionally, determine the area of a triangle given two sides and a non-corresponding angle. So that is also in this section. We do have a formula for this. If you recall from the notes, that formula, which is probably all the way down here, it's not letting me highlight, but I think you get the idea. It's right there. Okay. But yeah, that's the formula though. So could ask you a problem that asks you to find the area, and then you have to determine whether to use this formula or the other formula, which is down here, which is if you're given all three of these segments. So pretty much as I'm talking about all of this, I'm going in the order of the notes. So as you review this on your own, you can also follow along chronologically. So additionally, well, really that's everything in section 3.1, the law of sines stuff. Just using law of sines, maybe an application, maybe the area, given two sides in the non-corresponding angle. Move on to the law of cosines section. Well, when you use the law of cosines, well, it's when you can't use the law of sines. And so the two criteria for that, two sides in a non-corresponding angle, or all three sides in no angle. That's when you can use the law of cosines. So an example of that, so you have some triangle, and you have this side and this side. The non-corresponding angle would be right here, because it's non-corresponding because its corresponding side, we don't know it. So that's what makes it non-corresponding. And this is when you would use the law of cosines. So in some arbitrary setting, if you're not told which law to use, you need to know based off of this correspondence. If you do see a correspondence at all, it's probably law of sines. If you don't, probably law of cosines. You're definitely not going to get any correspondence if you have three sides, because there's no angle at all. So that one's kind of easy. And then also for 2, there might be an application problem, or you might have to find the area given all 3 sides, which evokes the formula from that section. This one right here. It's not working. You see that one. So that one, which you all seem to be pretty comfortable with in the homework. Okay, so law of sines and law of cosines, regular problems, application problems, and area problems. That's what sums up the first 2 so far. And so that brings us to vectors, pretty much everything we talked about regarding vectors. So be able to compare vectors. What does it mean for 2 vectors to be equal? What does it mean for 2 vectors to be opposite? This might be things worth considering. Would you be able to illustrate vector addition or subtraction or multiplying a number to a scalar? So remember, vector addition. I showed you 2 ways on how to do that. Draw one vector, and then where that one starts, you draw the second vector. Or you can make a parallelogram out of the 2. Subtraction, I mentioned that one. Scalar multiplication, I mentioned that one as well. And well, solve any application problems involving vectors. We talked about 2 main ones: forces acting at a point and cars and hills. So expect, something along the lines of one of those 2 to be on the test, if I do put one like that on the test. Section 3.4, that was going a little bit more into depth of vectors in coordinate systems. I could ask you to determine the magnitude and direction angle. So hopefully you remember how to do that. The magnitude is just the Pythagorean theorem. The direction angle involved, reference angle. Did a problem like that. So you might want to know, and you also did a problem like that in your homework, so you probably know how to do one of them comfortably. Determine the horizontal and vertical components of a vector. Those are just formulaic. There's a formula for one of the components, there's a formula for the other. Determine the dot product. That means you need to know what a dot product is. The dot product is a number and not a vector. So hopefully you remember that. The dot product is a number. It measures how, virtually in 2 dimensions, how perpendicular 2 vectors are, which means it spits out a number, which tells you pretty much the amount of orthogonality. So that might help, or if you just want to memorize it, I'll go for it. So determine the angle between a pair of vectors. This was one of the other formulas I'm just going to give. So for 4, I'm just going to give this one on the test. So if you remember from the notes, that formula I'm giving that one as well. So make sure, that means on your end, you need to make sure you know how to interpret this, such as one of the aspects of this, you need to know how to do a dot product. And then you need to know what this symbolism means. So that means you need to know what all of those things are. But I will give that whole formula on the test. And at the bottom there, apply vector arithmetic given two or more vectors and their corresponding components. So if I asked you to add two vectors together or multiply a number to a vector, you should be able to figure that out. Pretty much what we did in example 3 up here. So the vector arithmetic. Be comfortable with that idea. And so we can go ahead and move on to the discussion on radians. Of course, it's not really easy to obscure this. There's going to be some conversion problems on there. I think that's pretty obvious. I might ask you for an exact answer or an approximated answer. Exact answer means, yeah, multiple of pi. You try to figure out, I don't know, if you try to convert, say, 180 degrees to radians, and then you tell me the answer is 3.14, that's not an exact answer. Remember in class, I looked at the ratio by itself. 180 divided by 180 is 1, and then you throw the pi back in. So don't give me an approximated answer if I ask for an exact answer. Because it's cheating if you throw it in the calculator. It's not very fun. So, and then of course, I could ask you to convert radians to degrees. Or possibly determine the exact value for a radian measure. So exact value means you would put the pi aspect of the radian measure into the calculator. So if you have 3 pi over 2 radians, I don't know what that is offhand. I bet it's a pretty ugly number. But that would be an approximated one. And then an exact value or an exact function value, that would be like the ones we did where we converted to degrees. So pretty much all of these problems. So pretty much all these problems are up for grabs. And then that brings us to the last section, you need to know the arc length formula. So remember the arc length formula. That one's, of course, as the rest of these formulas are, they are all in the notes. The arc length. S is equal to r theta. You do need to remember that theta is in radians. A lot of people last semester kept that in degrees, so I took some points off, naturally. You convert it to radians, I will take off less points, possibly 0 points. Might be an application problem. Remember, we talked about the wheel that pulled up the weight. So there could be something like that. And area of a sector, which is another formula.
And it's 1/n of radius squared theta.
Let's see how you did.
And it's going to be in radians.
Yeah, r, or not r, theta is in radians.
That makes it a little easier. Because it's going to be in radians already. Now, if it's given an angle in degrees, then you have to.
Yeah, you have to
switch
convert.
over first.
Yeah, if they give you the degree and then ask you to
If
find the
If
area,
you're looking for theta, then it's easy.
unless they want the final answer in degrees. So that could be something else. And that's really, that's pretty much it. Like I said, the midterm is going to focus more in this section, but due to the cumulative nature of math in general, it's hard to exclude certain topics, such as one of the ones that come to mind. There is a problem that, well, there's actually two problems that come to mind. The exact value problem, that's pretty much an example of something we've done in previous sections that was geared towards the first test. And it required you to use triangulation or the quadrantal method if necessary and determine the reference angle and get a special triangle. Same thing for the direction angle problem here. So it also requires you to find a reference angle in order to determine the direction angle. So keep in mind, the reference angle is not the direction angle. The direction angle is pretty much the whole angle, and the reference angle is the distance to the closest part of the x-axis. So naturally, there will be some previous themes that will arise naturally, but their derivatives are based solely in the collection of problems you see on this page. So, with that being said, does anyone have any questions? Because if not, then there's not really much else for me to say unless there are any homework questions or any other questions about anything, really. Besides for that, if you don't have any questions, if you feel comfortable with everything you've submitted, if you feel comfortable going into the midterm, want to do it on your own, I've got nothing else to contribute. So that's really all I have.